Hello everyone, how are you doing all? Today we want to talk about common ratios. But before we go ahead and talk about common ratios, I want to remind you that last time we briefly talked about graphs of trigonometric functions. We talked about the graph of sine and the cosine, but it was brief because I didn't want to go so much into the details. Now today we want to talk about common ratios. They are angles whose ratios are known, okay? Or they are supposed or they expected to be known to each and every person. Something common is something which must be known by all. Like a common sense, you hope everybody, perceive it in a given way. So here we want to talk about these angles whose ratios are common, and in such situations when we are given such angles, we may not necessarily need to use a calculator, okay? Though nobody will stop you from using a calculator, but we may not necessarily, or we don't expect you to use a calculator when we are given such angles. These angles are 30 degrees, 45 degrees, and 60 degrees. So let me turn off my video and we get started, okay? Common ratios. So today we're talking about common ratios. Common ratios. So what are common ratios? These are ratios of 30 degrees, 45 degrees, and 60 degrees. So we write something that the angles 30 degrees, 45 degrees, and 60 degrees have ratios which are frequently needed, and these are obtained as follows. Obtained as follows. So to obtain the ratios of 30 and 60 degrees, we have to begin with 30 and 60 degrees. So let's say ratios of 30 degrees and 60 degrees. Okay, why 30 and 60? They are obtained from the same triangle. And what we do, we consider an equilateral triangle, okay? Consider an equilateral triangle. Consider an equilateral triangle. ABC. Something you must know about an equilateral triangle is that all sides have equal length and all angles are equal. But we know that the interior angle sum of a triangle is 180, and if the three angles of this equilateral triangle are equal, then each angle is 60 degrees. Okay, 3x is equal to 180, so x is equal to 60 degrees, assuming x is the angle we're looking for. Okay, so we have, let's push this to the next page. We have an equilateral triangle which is ABC. So this is the equilateral triangle. Supposedly this is the equilateral triangle, which is A, B, C. All the sides are equal, and the 2 units, okay, in length for each. Any length will work for you, but for convenience, 2 works better. But even if you call each side 4, 6, whatever, or x, it will still give you the same ratios, okay? Let's work with the 2. Now, we are saying that each angle here is 60 degrees. This is 60, this is 60, and this is 60. But, when we were talking about the ratios, sine, cosine, and tangent, we say that these ratios are defined only for right-angled triangles. And here is an equilateral triangle which is not having any 90 degree anywhere. So what do? We create the 90. We drop a perpendicular line from B, okay, to bisect the side SC, okay, perpendicular bisector of SC, okay, will divide this side into 2 equal parts, but since the length is 2, this is going to be 1 and this is 1, okay. This remains 2 and this remains 2. So we have created a right angled triangle, which is just half of the equilateral triangle, okay. So this is 60 degrees. And this angle is divided, okay. That line divides the angle into 30, 30. So this is 30 and this is 30. Okay, so what we do, let's call this point D, okay. What we do is we pick one of the right angled triangles, okay. So let's pick ABC, ABD. ABD, we know this is 1 unit, this is 2 units, and this is unknown. Let's just call it H. This angle is 60 degrees and this angle is 30 degrees, okay. So from here we can now read off the ratios, but before we read off the ratios, let's define or let's apply Pythagoras theorem to find the H. We know that the Pythagoras theorem states that the hypotenuse squared is the same thing as the sum of the square of the opposite and the adjacent. So it's equal to BD squared plus AD squared. So 4, okay, 2 squared is 4, is equal to BD, which is 1 squared. BD is H squared plus 1 squared. And therefore H squared is equal to 4 minus 1, which is a 3. So what is H? H is the square root of 3. And we are dealing with length, so we take the positive square root. Okay, so from here now we can say that the sine of 60 degrees, let's begin with 60. You know, sine is the opposite of hypotenuse. Which side is the opposite 60? This is the side. BD is the side that is opposite 60 degrees. So it's going to be opposite, which is BD divided by the hypotenuse AB. And the BD is H, which is now root 3 out of 2. So the cosine of 60 degrees is going to be the adjacent, okay. Oh, I don't want to write the word adjacent, so I just want to write the side, okay. Adjacent, so adjacent to 60 is the side which is AD, okay, divided by AB. What you have to know about the adjacent is it meets the opposite at 90 degrees. So the adjacent has to meet the opposite at 90 degrees, and the adjacent meets the hypotenuse at the angle under consideration. So adjacent is AD, which is 1, and this is a 2, okay. So we are left with tangent. Tangent of 60 degrees is, so the tangent is opposite, which is BD, divided by adjacent, which is AD, okay. This is root 3 out of 1, okay. So we have the ratios of 60 degrees, okay. If I summarize here something small for you, I'll say that the sine of 60, let me change the color and say sine of 60 degrees is root 3 divided by 2. Cosine of 60 degrees is 1 out of 2. And the tangent of 60 degrees is just root 3, okay. So these must be at your fingertips. They must be known to you at any time t, okay. Whether you have just woken up in the middle of the night and somebody asks what is the sine of 60, you say root 3 divided by 2, okay. Yeah, so it is really something very simple. Now let's go to 30 degrees. Okay, when it comes to 30 degrees, what we do, we go ahead and define, okay, this is not coming. Okay, what I'm going to do, let me delete this image and draw another one, okay. So this is the triangle we are considering, the right angled triangle. We have this side, this is A, B, and D. This angle is 60 degrees, but now our interest is here, 30 degrees. Okay, this is H, which we found to be root of 3, and this is 1, this is a 2. So when it comes to 30 degrees, the opposite changes. The side which is facing 30 degrees is now AD, and the adjacent will be BD. So the sine of 30 degrees is opposite, which is AD, divided by AB, okay? And this is 1 out of 2. The cosine of 30 degrees is adjacent, in this case it is BD, okay, divided by AB. And this is going to be root 3 divided by 2. Then the tangent of 30 degrees is opposite out of adjacent, and this is going to be 1 out of root of 3, okay? So we have the ratios of 30 degrees and the ratios of 60 degrees, okay? Something so interesting is that, okay, the sine of 30 degrees equals to the cosine of 60 degrees equals to a half. And the cosine of 30 degrees is equal to the sine of 60 degrees is equal to root 3 divided by 2. You can also see that the tangent of 60 degrees is 1 divided by tangent, okay, the tangent of 30 degrees rather, let me change it. The tangent of 30 degrees, if you check here, is 1 divided by tangent of 60 degrees, okay? And that is 1 out of root of 3. Sorry, tangent of 60, root of 3. So this must be at your fingertips because we are going to use this frequently, okay? In every day as we solve, as we start advancing trigonometry, these will appear so frequently, and therefore they must be at your fingertips. We have the sine of 30, we have the cosine of 30, and the tangent of 60. So what are we left with then? Okay, we say that the angles we are looking for are 30, okay, 45, and 60. So let's look at 45 degrees. To get the ratios of 45 degrees, we consider a right angled isosceles. We consider a right angled isosceles triangle, okay? Isosceles triangle. You consider a right angled isosceles triangle. Let's call it ABC, okay? We know that an isosceles triangle has 2 sides equal, okay? 2 sides are equal, so it is right angled and 2 sides are equal. This is a 90. So if this side equals this side, okay, any length works, but I'm working with 1, okay? 45 degrees. 45 degrees. Why are we saying 45 degrees? There is a property of triangles, okay? The angle subtended by 2 equal sides of a triangle, okay? At a common line become equal, okay? So this angle, if you have a triangle and this side is equal to this side, then this angle is going to be equal to this angle, okay? But already this angle is 90 degrees. Here we have a 90, and the other 2 angles must add to 90 and they are equal, so each is 45 degrees. So how do we get the ratios? Okay, we need to find the hypotenuse. The hypotenuse, let's call it R and use Pythagoras Theorem. This is A, this is B, this is C, okay? So AC squared is equal to AB squared plus BC squared. And this is R squared is equal to 1 squared plus 1 squared. But 1 squared, you know, is 1, so R is the square root of 2, okay? So we can now start reading off. Use any 45, will give you an answer. Let me use this 45, okay? If I use this 45, the opposite side is BC. The sine of 45 degrees is BC out of AC, okay? BC is 1 and this is root of 2, okay? So the cosine of 45 degrees is AB divided by AC, and this is 1, this is root of 2. Then the tangent of 45 degrees is opposite, which is BC out of AB, and this is just 1 over 1, which is equal to 1. So any 45 works, okay? And here they are interesting result for sure. We have seen that the sine of 45 degrees is equal to the cosine of 45 degrees is equal to 1 out of 2, out of root of 2. But sometimes we don't want to have an irrational value in the denominator. So what we do, we rationalize it, okay? And you can find this written as sine of 45 degrees is equal to cosine of 45 degrees is root 2 out of 2, okay? So it is the same thing. Root out of 2 is the same thing as 1 over root 2. They are the same, okay? And the tangent of 45 degrees is equal to 1, just 1, okay? So there is a relationship that you must know, and if you have been so observant, you can start the sine of theta is the cosine of 90 minus theta, okay? So the sine of 30 degrees will be the cosine of 90 minus 30, okay, which is the cosine of 60 degrees. We have seen already that those two are the same. And here I was saying that the sine of 45 degrees is the same thing as the cosine of 45 degrees, because 90 minus 45, okay, is the cosine of 90 degrees minus 45 degrees, which is the cosine of 45 degrees. So sine 45 degrees and the cosine of 45 degrees are the same. That's why if you plot the sine curve and the cosine curve, if you plotted these two curves, this angle is, okay, 90 degrees. This is 180 degrees, okay? Let me just plot for a few angles. This is theta, and this the value, the y value, y is equal to sine theta, and another y equals to cosine of theta. You know, sine and the cosine have maximum value 1 and minimum -1, okay? So if we plotted the values of sine and the cosine, the two graphs together, this -1 and this a +1, we discovered that the cosine of 0 is, and the cosine of 90 is 0. Oh, this is a poor graph for sure. I'm just doing it because I want to explain a point, okay? You want to plot this and then this, something like this. This is y equals to cosine theta. Then sine will attain a maximum of 1 at 90 degrees, and then it comes back to 0 at 180 degrees. Now this is the angle 45. When the two have the same values, 45 degrees, the sine of 45 is equal to the cosine of 45, and this is the value which is 1 over root of 2, okay? Yeah, other angles will come, you know, as you move, you keep repeating yourself, you get other angles, okay? Yeah, so we shall be talking more about this as we go on, but the point I want to explain is that the sine of theta is the same thing as the cosine of alpha if theta plus alpha is equal to 90 degrees, okay? That relationship is really so common and very useful sometimes in trigonometry. So this is what I wanted to teach you about common ratios. From here now we can go and start looking at trigonometric equations. So let's stop here for this lesson and begin another lesson looking at trigonometric equations. Now, before I go ahead and stop this lesson, there is something I want to tell you about. Traditionally, students are used to sitting in a classroom and a teacher comes and presents right on the blackboard. You know, you are seeing the teacher writing all the time, and we use that kind of system. Now, the times are changing. Because of this pandemic, things are changing. We are going online. Online studies have one problem. If you don't have money to buy data bundles, or if you cannot access Wi-Fi, it becomes expensive for you. You must have a laptop. You must, if you don't have a laptop, you must have a tablet, or you must have a very good smartphone. Now, what I have done, I have invested heavily in this program. I bought a very nice iPad, and I use an Apple Pencil. This pencil, you're seeing this pencil. This pencil is very expensive. It costs more than 500,000 Uganda shillings to buy this pencil, okay? But all what I'm doing is to help students access a file which is so small in size. If I decided to record my video and include it in every lesson, I have all those gadgets. I have very powerful Canon cameras that can do that. I have the microphones and everything. I can go ahead and do that. But that's going to be very expensive for you, because every file size I'm going to upload on YouTube will be very heavy and it goes with too much data. So to save on the cost of data, what I have done is to produce a very small file size, but with all the content that you need to study something. Okay, so don't take this lightly. I'm helping the nation. Nobody is paying me to do what I'm doing, but I want you to study. Okay, that's why I'm doing this. All what you need is just subscribe to my channel. I need to have so many subscribers. Later on, maybe when I get many subscribers, YouTube can start paying me, but I'm not really so much into the money. I will urge you to subscribe anyway, okay? And don't forget to hit the notification bell. That way, if I upload a video, you are notified instantly. Okay, let's meet in the next video as we begin the real trigonometry, because all this has just been introduction. We are going to start looking at the real trigonometry, and we shall begin by solving simple trigonometric equations in the next video. All right, I love you all. Have a nice day. Thank you.